Hi, welcome to our channel of IGNOU audiobooks, Indira Gandhi National Open University. School of Education, SOE. Certificate in Elementary Teacher Education, for Tripura State, CETE. Compulsory Courses. MES 023 Emerging Issues in Elementary Education. Block-1 Technology and Environmental Education. Unit-1 Fundamental Concepts of the Environment. 1.1 Introduction. Environment and development are inseparable. In 2004, the Nobel Peace Prize was awarded to Waimarie Maathai, a Kenyan environmentalist who had linked the critical issue of environment to development and peace around the world. Maathai had observed that the environment has been exposed to many human activities that are devastating to the environment and societies, such as widespread destruction of ecosystem. Environment is the surroundings in which we live, and development is what we attempt to do to improve our lot within the surroundings. One cannot think of development without its positive as well as negative impacts on the environment. Environmental studies have therefore become an indispensable subject for discussion at the local and global levels. Since the environment provides life support goods and services with no discretion based on gender, class, caste, region or religion, the entire society sees the common future here. This has led to increased participation of the specialists of different subjects, such as the humanities and social sciences, engineering, agriculture, forestry, public health, law, politics and economics, in the environmental studies. Thus, environmental studies have become an integrated subject. It has tremendous potential to provide a communication bridge between all the subjects which we study at school and college levels. It not only links the natural and social sciences together but sciences and society as well. Despite being a self-sustaining system, the environment, which provides air, water, food and power to us, is being constantly degraded through population pressure, pollution, and poor management. The effects of human activities on the environment and its consequences will be discussed in Unit 3 of this block. In this unit we shall learn about the basic structure of our environment. 1.2 Objectives. After going through this unit, you should be able to define environment, explain the various terms used in environmental studies. 8. Explain the structure and importance of the various components of the environment, and 8. Explain the ecological hierarchy. 1.3 Environment. Every society in the world is committed to improving the understanding, protection, and enhancement of ecological systems and human communities through better design, planning, management, and policy making. The study of the environment is a field that has crossed the boundaries of traditional disciplines and has challenged governments, NGOs, and individuals to look at the relationship between humans and their environment from a variety of perspectives. 1.3.1 Meaning. The term environment comes from the French word environnement, which means surroundings. Everything which surrounds us, whether living or a non-living, is a component of our environment. It includes the air we breathe, the water we use for our needs, the soil we cultivate, the flora and the fauna we enjoy. Broadly, it is defined as the sum of all external conditions affecting the life, developments and survival of an organism. The external conditions include both physical and biological. By physical conditions, also called physical environment, we mean non-living attributes like air, water, soil, climate, heat, light, noise, housing, radiations, and debris, whereas the biological factors, also called biological environment, include all types of flora, fauna and the microorganisms. The physical and the biological environments are interdependent. For example, deforestation leads to decline in wildlife population, biological environment, as well as increase in atmospheric temperature. Physical environment. In the human environment, social conditions like customs, religion, habit, and occupation are also included since they affect living conditions. 1.3.2 Classification of environment. Broadly speaking, environment is of two types: A. Physical or natural environment, and B. Cultural or social environment. Physical environment is the product of nature where there is no direct or indirect effect of human activity. Rocks, minerals, temperature, humidity, wind, rain, and other related non-living elements are example of physical environment. Cultural environment is man-made like railways, population density, cultural background of the people, the level of technological development and factors like personal, domestic, religious, educational, means of transport, market facilities, economic conditions, and policies of the government. 1.4 Various components of the environment. From the definition and classification of environment, you must have understood that environment is not a single unit but rather it is the combination of different interdependent components. Broadly classified, the environment consists of four components, namely I. Lithosphere, E. Hydrosphere, E. Atmosphere, and IV. Biosphere. Often we are asked by children why plants grow CIR don't grow in one or the other place. They also ask us the reasons for the difference in types of plants that grow in different places. Let us discuss the structure and function of the components of Earth, which will be helpful in understanding and explaining these phenomena. It will make our understanding of the environment easier. 1.4 Lithosphere. Lithosphere is the mantle of rocks constituting the upper part of the Earth. The uppermost part of the Earth is called the crust. The rocks constituting the crust are relatively less dense. These rocks are converted to comparatively loose material called soil through the process of weathering. The term weathering refers to disintegration and decay of rocks under the elements of the weather such as temperature, humidity, and rainfall. Thus, the texture of soil at a particular place is largely governed by the nature of the parent rock. Rocks are made of different kinds of minerals and the existing climate of that area. Since these two parameters, rock and climate, are not uniform, variations in the soil texture are observed from one place to another. For example, weathering of granite, basalt and their metamorphic rocks provide soil with considerable proportion of quartz grains mixed with fine particles. Similarly, soils formed by weathering of shale and slate rocks results in fine textured soils. Lithosphere is a very important co-NPO-ENT of the environment because it provides soil texture. Plants depend for their nutrients, water supply, and anchorage upon the soil. Soil is therefore any part of the Earth's crust in which plant roots are anchored. Thus, soil is the most significant part of the lithosphere. However, soil is not merely a group of loose mineral particles. It also has a biological system of the living organisms as well as some other components. Its components are divided into the following 6 categories. I. Mineral matter. Rocks are complex aggregate of minerals. Though more than 2,000 types of minerals are known, almost 99% of the Earth's crust is made up of only 10 to 12 types of minerals. Nearly 58% of the mass of the terrestrial rocks is constituted by feldspars, 16% by pyroxenes, 13% by quartz and about 4% by mica. Apart from these, calcium carbonate is also a common soil component. The common elements found in the Earth's crust and their percentage is given in Table 1.1. Table 1.1. Common elements found in the Earth crust. Look at the screen. E. Soil organic matter or humus. It is carbon-based material derived from living organisms. I. A. Plants, animals and microorganisms growing above and below the ground. It consists of polysaccharides, amino sugars, nucleotides, organic sulfur, and phosphorus compounds. The productivity of soil is determined primarily by the amount of these matters available in the soil. Higher the organic amount, higher is the productivity. Generally it constitutes less than 5% of the soil, but it varies over a wide range. For example, peats and mucks may contain as much as 95% organic matter. Any soil containing more than 20% organic matter is classified as organic. Functions of organic matter: it provides food for microorganisms, which are another living constituents of the soil, takes part in chemical reactions such as ion exchange, governs the physical properties of soil and sometimes contributes in weathering of mineral matters. Soil water. There are spaces in between the mineral particles, pore space, as well as between aggregates of soil. These spaces are occupied by water, which mainly comes from dew, rain, snow, hail, irrigation etc. This water is termed as soil water. It is a very important constituent of the soil since it is essential for the sustenance and growth of the plants. It is held in the soil by adhesion, attraction of water molecules to soil particle, and cohesion, attraction of water molecules to each other. The amount of water retained by the soil depends upon the size and shape of IHE mineral particles and the number of pore spaces between them. Thus different types of soils, a.g., sand, silt, clay, loam, have different water holding capacity. Sand has coarse texture with large particles and can hold water only loosely due to bigger pore spaces. The water in such soils generally runs down rapidly, reaching the deeper layers. Thus sandy soils are well drained. Clay soils, with high proportion of colloidal fractions as humus, can retain more water. Silt-like clay is able to retain more water. Loam, which is a mixture of sand and silt and/or clay, is supposed to be best soil for plants' growth as such. Soils are very fertile, being rich in nutrients, have proper aeration and hold fairly large amount of water. IV, soil atmosphere. It occupies the pore space between the soil particles, which are not occupied by water. About 35% of the volume of a typical soil consists of air-filled pores. The important point to be noted in the soil atmosphere is the percentage of oxygen and carbon dioxide. These are different from those in the atmosphere because TLIE decay of organic matter in the soil consumes oxygen and produces carbon dioxide. As a result, the concentration of oxygen in (N comparison to the atmosphere decreases in the soil and carbon dioxide increases. This process also increases the amount of carbon dioxide in groundwater, making it more acidic because carbon dioxide is soluble in water and the resulting solution is an acid called carbonic acid. So the increase of carbon dioxide causes disintegration of the carbonate minerals, particularly calcium carbonate, CaCO, and the metal becomes free and available as a nutrient to the plant. Biological system. Apart from the above mentioned constituents of the soil, biological systems are also present. Each soil has a distinctive flora as well as fauna of bacteria, fungi, algae, protozoa, molluscs, arthropods etc. Biologically, the soil is the weathered superficial layer of the Earth's crust in which the living organisms grow and also release the products of their activities, die and decay. The role of biological system is very important as they play the role in biogeochemical cycle, which we will discuss in the next unit. Micronutrients and macronutrients, dissolved salts essential to life, are termed as nutrients. These nutrients are also called biological salts. They may be divided into two groups, the macronutrients and the micronutrients. The macronutrients include elements and their compounds needed in relatively large quantities, for example carbon, hydrogen, oxygen, nitrogen, potassium, calcium, phosphorus, and magnesium. The atmosphere and water are the source of carbon, hydrogen, and oxygen. The other essential macronutrients are obtained from the soil. Nitrogen, phosphorus and potassium, NPK, are commonly added to soil as fertilizer. The micronutrients include those elements and their compounds, which are necessary for the operation of the living system but are required only in minute quantities. If present in high quantity, pose toxic effect. At least 10 micronutrients are known to be necessary for plant production. They are iron, manganese, cobalt, zinc, molybdenum, boron, sodium, chlorine, vanadium and cobalt. The source of these minerals is the weathering of the rocks. Most of these micronutrients serve as components of essential enzymes. Some of them, such as chlorine, manganese, iron, zinc and vanadium, take part in photosynthesis. Soil profile. Iron mental education. As you know, weathering of rocks is the primary stage of the soil formation. Now, suppose at a particular place the parent rock is weathering over a period of time. There develops layer of the soil one over the other in progressive state of maturity. Thus the composition of one layer will be different from the other layer. The vertical arrangement of these layers is called soil profile, which is a very important method to identify and describe the soil. A generalized and simplified soil profile has four major Divisions arrayed in descending order from the surface of the soil, 0, A, B, and C horizons, with 2 subdivisions of A, C. Fig. 1. 1. Look at the screen. Their predominant characteristics are 0. Primarily dead organic litter. Most soil organisms are found in this layer. A layer rich in humus, consisting of partly decomposed organic material mixed with mineral soil. A region of extensive leaching of minerals from the soil. Plant roots are concentrated here because minerals are dissolved in water in this layer. B a region of little organic material whose chemical composition resembles that of underlying rocks. Say minerals and oxides of aluminium and iron leached out of the overlying A horizon are sometimes deposited here. C primarily weakly weathered material, similar to the parent rock. Calcium and magnesium carbonates accumulate in this layer. Thus, it is clear that as we go down, the amount of organic content decreases. So, the topsoil or horizon, 0, is of maximum biological activity. Hence, it is of considerable importance for the vegetation cover and agricultural crops. SOE, topsoil should be conserved, but unfortunately reckless deforestation over the years has led to considerable loss of topsoil. Its consequences we will read as soil pollution in Unit 3, 1.4.2 Hydrosphere. The hydrosphere is that part of the earth where water is available either in the liquid or in the solid form. It includes the surface as well as the underground water and covers 3/4 of the total area of the earth. This is a very important part of the Earth's life support module, since it provides water and also functions as an air purifier, temperature moderator, because latent heat of water is very high, and waste assimilator. Apart from this, its excellent solvent nature is also a great contributor for the sustenance of life. The worldwide distribution of water is given in Table 1.2 below. Table 1.2, Worldwide Distribution of Water. Look at the screen. It is obvious from the given data that the major portion, about 97% of the available environmental education water is unfit for human consumption and other use because of high salinity of the remaining 3%, 2% is locked in the polar caps and 1% is available as fresh water. This distribution of water is almost fixed due to hydrological cycle. Hydrological cycle is a process by which available water circulates between the land, ocean, and the atmosphere by the process of evaporation, transpiration, precipitation, runoff, and groundwater movement. The cycle of water is shown in Fig. 1.2 below. TB circulation of the water of the hydrosphere is responsible for the weather are the landmass. The annual evaporation of 3.5 xio5 kmf from the oceans and of 7.0 x low 4 km 3 from land areas results in an annual precipitation of 3.2 x low 5 km 3 over the world oceans and 1.0 x low 5 km over land area. The rain falling on the continents is partly absorbed by Earth's surface to become groundwater and partly flown into the streams, which finally returns to the sea. Look at the screen. Fig. 1.2, a systematic diagram of hydrological cycle. Only the groundwater and the surface water are in direct use of man. Both the ground water and the surface water together constitute less than 1% of the total available water. Even this water is not present in its pure form. It is of different characteristics, partly due to anthropogenic activities and partly due to natural processes. Groundwater depends upon the quality of the soil through which it passes from the surface to deeper layers of the earth. Although in the process of infiltration through the ground, the water gets rid of most of the microorganisms originally present in the surface water, but during the process it dissolves a much of salts present in different soil profiles. This enhances the salinity of the groundwater and deteriorates its quality. On the other hand, the surface water contains a much of organic matter and mineral nutrients, which was originally present at the topsoil. Apart from this, the surface water is also contaminated with runoff from agricultural fields containing pesticide, fertilizer and soil particles, waste chemicals from industries and sewage from cities and rural areas, leading to deterioration in the water quality called water pollution, which we shall discuss in Unit 3 of this course. 1.4.3 Atmosphere. Atmosphere is the mixture of the gases that envelops the Earth's water and landmass. Up to a height of several kilometers. It is held close to the Earth because of Earth's gravitational pull. The share of its major components are 78.05% nitrogen, 20.95% oxygen, 0.94% argon and 0.03% carbon dioxide. Hydrogen, nitrous oxides and ozone are also present in very small amounts. This composition is consistent up to an altitude of 9 okilomillilsecond above the surface, but the water vapor content of the atmosphere ranges from more than 5% in the tropics to less than 0.001% in polar region. In addition to its function as a medium, its oxygen and carbon dioxide chemically affect all forms of life through photosynthesis and respiration. Thus it is the atmosphere which makes the life possible on the Earth. The concentration of these gases in the atmosphere varies with organic and industrial activities leading to the contamination of air known as atmospheric pollution. Atmosphere, based on temperature pattern, vertically Earth's atmosphere can be roughly divided in 5 major zones as depicted in the Fig. 1.3. Look at the screen. Fig. 1.3, Temperature profile of the atmosphere. I. Troposphere, the zone immediately above the Earth's surface is known as troposphere. It extends up to a height of 20 kilometers above the equator and about 8 km over the poles. The temperature in this zone decreases with height being as low as 60 degrees Celsius at its upper extreme. The troposphere contains 75% of the mass of the atmosphere and more than 9/10 of its water vapor, dust and smoke. Most of the anthropogenic activities take place in this layer. It is the most turbulent part of the atmosphere. Stratosphere, the layer next to troposphere is called stratosphere. It is about 3 okilomillilsecond in thickness. In this zone the temperature rises with height. The temperature in this zone rises from 60 degrees Celsius to about 0 degrees Celsius in its upper layers. The rise in temperature in this region is due to the F-formation of ozone. Because of the very low temperature, there are no clouds, dust or water vapor. There is also no convection, hence the mixing is very slow. Because of the slow mixing in the stratosphere, the residence times of molecules or particles are quite long. If the eye pollutants can somehow reach or are injected into the stratosphere, they pose long-term global threat compared to their impact in the troposphere. Ozone layer depletion is one of its consequences. In Unit 3, we will discuss it in detail. Mesosphere, above the stratosphere is mesosphere. This region of the atmosphere is characterized by cold temperature. In this region the temperature decreases with height due to low levels of ultraviolet absorbing gases. The mesosphere extends roughly to 80 kilometers and the temperature drops to about 95 degrees Celsius to a level of some 80 to 90 kilometers above the Earth's surface. Ionosphere or thermosphere, it is extended up to a height of 600 kilometers. Absorption of solar radiation causes an increase in temperature with height in the ionosphere. This layer is called ionosphere because it contains electrical charged icons such as O, 0 inches no, etc. Exosphere. Exosphere is the uppermost layer of the Earth's atmosphere. The upper limit of this layer is uncertain as the exosphere acts as a transitional layer between the Earth's atmosphere and the space. The outer part of the exosphere is called magnetosphere. All the layers of the atmosphere are of vital importance to the environment because together they form the total blanket of air to the biosphere. 1.4.4 Biosphere. It is that part of the Earth which overlays the atmosphere where natural life is possible. It denotes the realm of living organisms and their interactions with the physical environment, i.e. lithosphere, hydrosphere and atmosphere. Both the biosphere and the physical environment are influenced by each other considerably. For example, the oxygen and carbon dioxide levels in the atmosphere depend entirely on the plant kingdom through the process of respiration and photosynthesis. Similarly, the biological world is intimately related with the energy flows in the environment and water chemistry. In order to get a clear understanding of the biosphere, it will be useful to learn about organizational hierarchy, also called ecological hierarchy, because it is placed at the top of this hierarchy. Let us first try to understand the ecological hierarchy. 1.5 Ecological hierarchy. By going through the sections above, you must have become familiar with the basic components of the environment. Now let us discuss how these components make the environment operative. To fully understand the environmental operations at the ground level, it is useful to think in terms of levels of ecological hierarchy. The ecological hierarchy is similar to geographical or political hierarchy. Hierarchy is defined as an arrangement of graded series of compartments. You can understand the hierarchy system by comparing the two columns of Fig. 1.4 given below, representing two different hierarchies. One is for geographical hierarchy and other is for ecological hierarchy. Look at the screen. As you can see in column A of Fig. 1.4, in the geographical hierarchy the world is placed at the top. Within the world there are continents, and within continents there are countries, and so on. Similarly, in ecological hierarchy we show biosphere at the top. And within the biosphere we have biogeographic regions. Within biogeographic regions there are biomes. Within a biome there are landscapes, which in turn are composed of many ecosystems. And finally it also descends down to a level of an individual organism. So in order to understand the biosphere we need to learn the various terms used in ecological hierarchy. Let us learn these terms. I. Population. It is a group of the same interbreeding organisms that live together in a given area. For example, population of zebra in a forest. E. Biotic community. It includes every individual of the population living in interacting in a given area. Ecological community includes only the living organisms, e.g. all plants, all animals and all the microorganisms. E. Ecosystem. The ecosystem is the whole complex of organisms and the physical environment they inhabit. A term parallel to ecosystem, often used in German and Russian literature, is biogeokonosis. The term biogeokonosis means life and earth functioning together. At this level in ecological hierarchy, the abiotic system figures and makes the community self-regulating. We shall discuss ecosystem in detail in the next unit. IV. Landscape. Groups of ecosystems along with human artifacts make landscape. The landscape is categorized in three categories: a fabricated, a domesticated, and a natural. Fabricated landscape. It is also called developed sites. It includes cities, industrial areas, and transport corridors such as roads, railways, and airport. From the standpoint of energy use, the fabricated environment is a fuel-powered system. Fuel over red means the source of energy is fossil fuel like coal, oil, and natural gas. The fabricated landscape actually covers a small area of our total landscape, but they are energy intensive. So they require much energy and create so much waste, heat, and pollution. They have enormous impact on the other two types of landscape. Domesticated landscape. It is also called cultivated site. It includes agricultural land such as the farms, managed woodlands and forests, artificial lakes and ponds etc. From the energy point of view, this part of our landscape is called subsidized solar-powered system. The sun provides the basic energy, but the source is augmented by human-controlled work energy in the form of human labor, machines, fertilizer, and so on, much of which is derived from fuels. Natural landscape. It is also called natural site. These types of landscapes are characterized by the term self-maintaining. It operates without any energetic or economic control of humans. It includes the natural forests, rivers, mountains, etc. From the standpoint of energy, these are basic solar-powered system. It is dependent on sunlight and other natural forces, such as rainfall, water flow, and winds, which are indirect forms of solar energy. Biomes. To be able to understand biomes well, we must understand two related ecological terms called succession and climax. Succession means turnover of species. A typical species always tries to be in equilibrium with the prevailing environmental conditions. But the environment keeps on changing with time for the following reasons. A. variation in climatic and physiographic factors, and b. the activities of the species of the communities themselves, as a result of their growth, dispersal, reproduction, death, and decay. The environmental changes bring about apparent changes in the dominance of the existing community. As a result, sooner or later the dominant species is replaced by another community at the same place. Remember the famous incident of extinction of the dominant dinosaurs. They were extinct because they were unable to cope with the climatic changes. This process continues and successive communities develop one after another over the same area until the terminal final community again becomes more or less stable for a longer period of time, and it maintains itself in equilibrium with the climate of the area. This final community is called climax community and the stage as climax stage. Thus, climax may be defined as the end point of the successional sequence, or SEER, a community that has reached a steady state under a particular set of environmental conditions. Now let us define biomes with the co-tilde-tilde-subt of succession and climax. The term biome was put forward by Clements and Shelford, 1939. According to them, under similar climatic conditions, there may be parallel development of more than one community, some reaching the climax stage, other under different stages of development. This complexity of several communities in any area, represented by an assemblage of different kinds of plants and animals sharing a common climate, is called a biome. Since similar climatic conditions prevail over a large region of the Earth, biome is a bigger unit than landscape. Biomes are distinguished from each other on the basis of temperature, amount of rainfall, and solar radiation. The major land biomes are tundra, a treeless region in the north with an Arctic climate, where underlying layer of soil is permanently frozen. Taiga, the northernmost forest below the tundra across Europe, Asia, and Northern America. Temperate deciduous forest, the eastern US, England and Central Europe, containing trees which shed their leaves perennially. Tropical, region of high temperature and ample rainfall. Grassland, also called savanna, receiving less rain, and deciduous forest. Desert, the most arid regions with hot days and cold nights. Aquatic biomes are either marine, referring to oceans and other salt water bodies, or freshwater, such as lakes and rivers. Biogeographic region, the major continents and oceans are the biogeographic regions, each with its own special flora and fauna. Biosphere, it is a widely used term for the Earth's entire ecosystem functioning together. The term ecosphere is often used synonymously for biosphere. But, according to some authors, biosphere is all the life on the Earth, i.e. all the communities, and ecosphere means all the life and interacting non-living materials, i.e. all the ecosystems. Since all the levels in the ecological hierarchy involve life and biological process, we can conclude that biosphere is that portion of the Earth in which organisms can live, i.e. the biologically inhabitable soil, water, and air. 1.6 Summary. In this unit we have learnt about the definition, importance and types of environments. We have also learnt about the basic segments of the environment, i.e. lithosphere, hydrosphere, atmosphere and biosphere. Soil formation is one of the greatest contributions of the lithosphere. We also realized that although 3/4 of the Earth is covered by water, only 1% of the total water is fit for human consumption. The amount water in various water bodies is almost constant due to hydrological cycle. Atmosphere has a fixed composition of gases present in it, and any excess change in this composition is likely to cause air pollution. We also read ecological hierarchy, where various terms often used in environmental studies have been made clear. Thank you for watching. We will see you in the next video with the next chapter.